Chemistry likely question for JAMB 2026. Question 1. Calculate the oxidation number of sulfur in. So let's quickly solve this particular question on oxidation number Na2S2O6. So the oxidation number of Na, which is sodium, is. We are looking for the oxidation number of sulfur. Our sulfur, we represent it as X multiplied by the subscript 2 plus the oxidation number of oxygen is -2 multiplied by the subscript 6 equals 0. So 1 multiplied by 2, that's 2, plus X multiplied by 2, that's 2X, plus -2 multiplied by 6, that's -12 equals 0. So let's make 2x the subject of the formula. So 2x equals, let's take -12 to the other side, to the right hand side, that's 12 minus 2. When taking 2 to the other side, it will turn to -2. So 2x equals 10. Let's divide both sides by 2. Divide 2 by 10. So 2 cancel 2. 2 divided by 10 will give us 5. So x equals 5. So the oxidation number of sulfur in Na2S2O6 is 5. And we can find the option in option C, which is the appropriate answer. Question 2. An element X forms a volatile hydride XH3 with a vapor density of 17.0. The relative atomic mass of X is A 30.5, B 31.0, C 32.0, D 29.2. So let's quickly solve this particular question. Firstly, our molecular mass equals vapor density multiplied by 2. So our vapor density, according to the question, our vapor density is 17.0 multiplied by 2, that's 34.0. So to get the relative atomic mass of X, we are going to subtract 34 from 3, which is the subscript of hydrogen. So 34.0 minus 3 will give us 31. So X, the relative atomic mass of X is 31. Question 3. Two atoms represented as 235 uranium and 238 uranium are A isomers, B allotropes, C isotopes, D anomers. So if you look at these two atoms, what we are going to notice is that the atomic number are the same while the mass number are different. And the definition of isotope is a phenomenon whereby we have the same atomic number but different mass number. So these two atoms represented as 235 uranium and 238 uranium are isotopes. They are isotopes, different mass number and the same atomic number. Question 4. The carbon atom in ethene are AsP3 hybridized, BsP hybridized, CsP2 hybridized, D not hybridized. So we have sp, sp2 and sp3. So for sp, that's where you can find the alkyne. For sp2, alkene, and for sp3, alkane. So the carbon atom in ethene is under alkene. So sp2 is the appropriate answer for this particular question. sp2 hybridized. So if you are interested in joining Learn with Israel tutorial, just share this number right here on WhatsApp to join our tutorial. It's very important. Question 5. The two functional groups in the above compound are, if you can identify the two functional groups in this compound, just drop the answer in the comment section. The two functional groups in the above compound are A alcohol and amine, B arachidonic acid and amine, C aldehyde and acid, D ketone and arachidonic acid. So the two functional group there is COOH and NH2. COOH is arachidonic acid, while NH2 is amine. So the two functional group in the above compound is arachidonic acid and amine, which you can find in option B, which is the appropriate answer. Question 6. This question is organic chemistry question. The IUPAC name of the compound above is A. 2,2-dimethyl-butyl-1-ine, B. 2,2-dimethyl-butyl-1-ene, C. 3,3-dimethyl-butyl-1-ene, D. 3,3-dimethyl-butyl-1-ine. So the first thing is to count and check the lowest number. So let's start counting from the right. 1, 2, 3, 4. Let's count back to the left. 1, 2, 3, 4. So we are going to go for the right, from the right to the left. The reason is because we can find the double bond attached to the last carbon. So 1, 2, 3, 4. 1. Let's first identify the parent name. 1, 2, 3, 4, which means we have boot. The parent name is boot 1 in. How is it 1 in? Because the first one, the one here is under the double bond. 1, 2, 3, 4, boot 1 in. 1, 2, 3, 4. 4 means boot, and we have this one here, and this double bond here means it ends with suffix in. Assuming it is single, that will be in. Assuming it is triple bond, that will be ine. It will be boot 1 ine. But since it is double bond, that will be boot 1 in. So since we already know our parent name as boot 1 in, the next thing is to check out the substituents. We have 1, 2, 3. We have two substituents. We have one methyl and we have another methyl here. So that will be dimethyl. Di means 2. That will be dimethyl. And the number where it falls under is 3. So if we now want to write it, it will be 3,3-dimethyl butyl-1-ene. 3,3-dimethyl butyl-1-ene. If you need more knowledge on this organic chemistry, in our paid tutorial, we've treated that. So if you need more understanding, just shout this number right here to join our paid tutorial. It's very affordable. So, and if you check our answer here, we can find our answer in option C, 3,3-dimethyl butyl-1-ene, which is the correct answer. Question 7. Which of the following reagents will confirm the presence of unsaturation in a compound? A. Phenylene solution, B. bromine water, C. toluene reagent, D. Benedict solution. So one of the reagent that confirm the presence of unsaturation is bromine water, which we can find. Unsaturated compound include alkene and alkyne. Unsaturated compound include alkene and alkyne. While saturated compound, we have alkane under saturated compound. So alkene and alkyne can decolorize in bromine water. They can decolorize in bromine water. Why alkane do not decolorize in bromine water. So the reagent which confirm the presence of unsaturation in a compound is bromine water. For phenylene solution is used to test for reducing sugar like glucose. And for Benedict solution is used to test for reducing sugar like monosaccharide and disaccharide. Example of disaccharide includes sucrose, because the combination of glucose and fructose will give us sucrose. So that's about that. And for toluene reagents, we ammoniacal silver nitrate, that is used to test for toluene reagent is used to test for ammoniacal silver nitrate. So make sure you take note of that. So question 8. The oxidation number of chlorine is +1 in. So we have 4 options. So let's solve for the first. Let's start from option D. Let's start from option D. We have NaClO. Let's start from option D. We have HCl. The oxidation number of hydrogen is +1 plus we are looking for the oxidation number of chlorine, so let's represent it as x equals 0. So by making x the subject of the formula, +1 will come to the other side, which will turn to -1. So x equals -1. For NaCl, the oxidation number of sodium is +1 plus x equals 0. So by making x the subject of the formula, +1 will go to the right hand side, which will turn to -1. For KClO3, potassium is represented as K. So K, that atomic number, the oxidation number of K is +1 plus X plus the oxidation number of oxygen is -2 multiplied by the subscript 3 here equals 0. +1 plus X -2 multiplied by 3 will give us -6 equals 0. So x equals 6 minus 1. If you take -6 to the right hand side, you turn to 6. And if you take 1 to the right hand side, you turn to -1. So x equals +5. So let's solve for the last one, which is NaClO. For Na, the oxidation number of Na is +1. I look for the oxidation number of chlorine, so let's represent it as x plus -2, because the oxidation number of oxygen is -2 equals 0. So let's make x the subject of the formula. So x equals, by the time we take -2 to the right hand side, we turn to +2 -1. +1, once +1 go to the right hand side, we turn to -1. So 2 minus 1 will give us 1. So the oxidation number of chlorine is +1 in NaClO, which is option A, which is the appropriate answer. If you are interested in joining our paid tutorial, just share this number right here on WhatsApp. We have tutorial for science, arts and commercial for JAMB 2026 preparation for the exam. So we have, as at now, we have 27 days to prepare, and we'll be starting our final revision class by April 1. So do well to join. Make sure you don't procrastinate on this. So let's continue. We have 2 questions to go. Question 9. Potassium vapor burns with A blue flame, B violet flame, C golden yellow flame, D brick red flame. Let's start from option D. Calcium burns with a brick red flame. Make sure you take note of that. For golden yellow flame, sodium burns in golden yellow flame. Potassium burns in violet flame, while copper burns in blue green flame. So with this, we should be able to identify the appropriate answer. Potassium vapor burns with a violet flame. JAMB do ask this question. Make sure you take note of it. So question 10. This is the last question. If 200 centimeter cube of a certain gas weighs 0.5 gram at STP, calculate its molar mass. So 1.0 mole of gas at STP occupies 22.4 dm cube. So we have our option F, A 56, option B 112, option C 28, and option D 24. So our molar mass, the formula for molar mass equals mass over volume. Our mass is 0.5 and our volume is 200 centimeter cube. But we will have to convert it to dm cube. And how do we convert it to dm cube? We divide by 1000. We divide by 1000 to convert 200 centimeter cube to dm cube. So let's divide 200 divided by 1000 would give us 0.2. 0.2. So let's bring it a 0.2. So our molar mass, this mm is molar mass. So 0.5 divided by 0.2. So that will give us 2.5. That's not all. We have to multiply it with the constant standard volume here, which is 22.4 dm cube. So 2.5 multiplied by 22.4 dm cube. So let's press our calculator. 2.5. I hope you are solving the question the way as I am solving it. 2.5 multiplied by 22.4. That would give us 56. 56. So that's not all. We have to add the unit. The unit for molar mass is gram per is unit for molar mass is mole per dm cube. Mole per dm cube. So the correct answer is 56 mole per dm cube, and you can find that in option A. Option A. So we've come to the end of this video. If you find this helpful, please like, share and subscribe. See you in the next one.